So as Kelly was introducing, today we're going to be discussing in this webinar MPS's power solutions for accelerator cards. As we look at the agenda for today, so the first thing that we want to cover is, really what are the performance and mechanical requirements that make acceleration cards unique, and also briefly talk a little bit about introduce the market and kind of what we're seeing. A lot of different applications and things have come about. So there's a lot of different areas to which MPS is providing these new solutions. And then we're going to focus on really the core solutions for these devices. MPS has a very good offering of core power solutions for these very high current demand devices. And then we're going to briefly talk about our split VN solution, which is really a one-of-a-kind novel solution on the market, which is really a key application use for accelerator cards. And then talk a little bit more about some other ultra-thin auxiliary power solutions we have, and then really kind of summing up how all of that makes designing these accelerator cards simpler and easier using MPS power modules. So just a little background on the market. So accelerator cards are really being driven by this big data market. As we all know, the world continues to grow, especially with some of the recent events around the world. We've seen, the data hungry data centers continue to expand. We've seen, the implementation now of 5G networks. So as we continue to see more and more data and all of these different processes that can be used from, TensorFlow to machine learning, simulation engines, those all require more and more computational power. And so as companies look to scale up their data computation abilities, they're developing these accelerator cards to help process and manage all of that data flow. And so we're seeing them really break out in a bunch of different markets. Originally, they had started more early on for gaming computing with the graphics accelerator card. Now they've really expanded into data centers. We've seen telecom, edge AI, which is really for transmission purposes. So we've seen a lot more like edge networking cards where companies will need to compress data before sending it out. So this can come in handy with like security cameras or IoT. And then as well as cybersecurity and fintech, we're also seeing big strides there for companies to develop these cards to be able to, further deal with all the data influx that they're getting. And as we'll talk about too, they generally come in standard form factors, and that's way because all of the companies that are developing them, they have to be able to fit them into a standard server or standard rack configuration. So this is where it makes it to be a challenge. And that's what we'll discuss a little bit, is about how, MPS can help address that challenge from all the different requirements that are brought up by accelerator cards. But that's what we're really seeing is the overall, and why we wanted to do this webinar, is there's been really a driver forward, and will continue to be a driver forward of more and more of these companies developing these types of really high performance cards that really have these kind of unique set of requirements. So as we take a look at, kind of the performance and mechanical requirements. So just to kind of look, to get everyone on the same page for a typical architecture of one of these cards, they typically come in a form factor like this shown on the right, where you have a case over a typical PCIe standard card. And just as kind of a general mock-up, for what, there's so many variety of cards out there in terms of what customers can place. But in terms of the general form factor, usually they're a PCIe bus with then some sort of mounting slot. And this can create for, when customers now are starting to add, because of the standardization of the PCIe bus, we can have different size height cards and different size slot widths, which I'll discuss too. But in general, a lot of these cards now, they have to have some sort of FPGA SoC at the core. And then, to support that, they have a bunch of DDR memory, and then there's some other auxiliary, plus, whatever your communication ports are. And what we're seeing now is that, these cards, depending on the form factor, they can be mini, PCIe, things like that, is that the space available on the card and the height and requirements are very constrained. And so really when it comes down to footprint space available, depending on whether you were talking about the back or the top side of the card, there is minimal power space available for most of these accelerator cards. And when they're trying to then fit it all under their compartment or the shell heat sink, it creates even more of a challenge when trying to deal with the power. And if you've ever seen one of these cards or dealt with them, you'll know that the power probably takes up the most real estate, especially if on the design they're using a traditional discrete design. And so now what we've seen is, customers want to be able to go and use they want to be able to stack more onto their cards. And so what we're really seeing, is just kind of this trend where, computing density continues to be pushed to be increased. We're seeing that the total power is being increased, especially as the node voltages on some of the core devices for the FPGAs continues to drop. The core demand current continues to rise. And on some of these cards, as the computing densities continue to rise, they're looking to actually stack multiple devices onto a single card. So that means, you could have two FPGAs or FPGA SoC or an FPGA and a networking, interface. So there's a lot of things that are now trying to be packed onto these single cards, and the board space just continues to drop and what's available. So it's always about trying to maximize the real estate that's available on these cards, and that's something that we've really seen where MPS can really have a big impact. And now allowing customers to design to their original compute parameters and not have to worry about, can I meet the mechanical specs? Can I meet the footprint area available? So looking at, this is one of the big things about accelerator cards is really the profile requirements. And, this is where MPS, as I'll talk later in this webinar, has really been able to shine, is that, depending on where the power is being placed, there's different space available. So on the top side of the board, we have, that's typically where most of the computing or memory will be placed, or like I said, some of the interface connectors like the SFP ports. And this, makes us to have a limited available amount of footprint space. But we do have more height available because typically in some of these cards, as you can see, it really depends on where the industry is or where the customer is designing their card. We do have cards that we've seen that go all the way up to like a triple wide slot. They're much more rare. Typically, it's in the 1 to 2 width slot. And in order to increase the computing density even more into a server rack, most companies are going to want to stick within that 1 wide slot width. If they try and push, depending on airflow and everything, they might have to go up to a double wide slot card. But this means, that they do have more space on top. It is limited depending on how much big the fan heatsink. But typically, it can be 5 to 8 millimeters, whereas on the bottom side, now we're limited because of the low profile availability, which can reduce it down to only, less than 1 millimeter to 2 millimeters, depending on the card design. But now we usually have a lot more footprint space available. So, traditional power solutions, they're kind of constrained, or they either, they have kind of one footprint, especially for discrete. The inductor can be the most difficult thing to place because a lot of customers, they'll try and put the switcher on the back and the inductor on the top, because the inductor is usually going to be more than the 2 millimeter requirement, especially for the core. But this can create all kinds of noise issues, and is not recommended to do through vias for switching like that. So, that's where MPS's inductors can come in, and now our power modules with integrated inductors, where now, we can provide solutions in both of these categories, and that makes us, a really key solution provider for these cards. And that's really what we've seen, is being able to capitalize on all the real estate available for these power solutions. Another thing to keep in mind as, we kind of finish off the requirements for these cards is that, they do demand very high power performance. Because they're powering usually their core devices, a FPGA or SoC, the transient requirements can be extremely high. They also need low ripple, very high efficiency, and demand a very high core current. And as we've seen, as the end users that actually implement the cards, they're looking for high efficiency because they want to be able to meet their standards, say across their data center. They want to make sure that their whole data center is meeting a certain efficiency mark. And then from a computing side, when the software engineers are being able to use those cards, they want to make sure that they're able to max out the card's performance. And that's really where we don't, we see customers before with discrete solutions having to cut back on the performance because they have to limit the power that they can provide. But now with our module solutions, they're no longer limited in this way. And we've really seen customers then being able to pull out the full performance of the device that they've spec'd, which can really bring a big upsell for the customer, as well as anyone designing one of these cards. So now kind of jumping into MPS's solutions, in specific our module solutions. As we've seen, these are really been a major game changer for this market. So our power modules here at MPS, one of the big focuses is on the small size of the solution. And as I've kind of laid out in the first part of this webinar, is that's key for accelerator cards. Is whether it's the height or whether it's the footprint space, that's key. And our modules, we integrate the inductor with the power stage and several other passives inside a single package. And so, as I'll show in the coming slides, this gives us a big advantage in terms of how we reduce the footprint size, and also, it gives us flexibility in terms of how we create that footprint, whether it's a stacked, module for 3D packaging, or whether we're going for an ultra thin profile design. Modules then also offer other key benefits that we'll touch on in terms of the simple layout. They require minimum components. So all of this together really makes them for a key, a very key target application for these accelerator cards. And that's really where we're seeing them fit, is into this market because of these key advantages. So we actually, last year, we did a demo here at MPS for a accelerator card power demo. And we'll dig into this demo actually and what it's showing a little bit later on. It is showcasing our split VN solution. But what's key here is to take note on a lot of the size of our power modules, and how in this solution here that I'll discuss, this is a 200 amp solution that we're showing here in this compact form factor. And this is one of the areas, as I've mentioned, that we really accelerate so much, is the solution size. But we did do this demo, and I will be touching on it more in terms of what we're showing off here, the different devices that we're really promoting towards this market, and how it can really help you guys as customers to provide figure out solutions for your own designs. So really kind of showcasing, talking about the solution size and how we're able to reduce, the number of rails, is, we might see a typical discrete solution that occupies, really because of the inductors, can occupy quite a bit of space. And then, we're able to consolidate that down, not only by reducing and removing the inductor from the equation, but also that we have these multi-output power modules. And so this can create a very, very compact solution and reduce the footprint even more. We typically can reduce the footprint requirement by up to 70%. So this makes a really big difference. And kind of, looking at a general design here of, say, a generic device on the core rail, typically you can have, several up to a dozen or more rails. And just showing here, with our multi-output devices, we're able to consolidate those all down to really reduce the footprint size. And this makes it so that, any designer, things like that, one, they can reduce their total BOM. They can also reduce the external components, as I'll talk about more. but now we can really reduce that solution size, and especially in the top side of the board, as is shown here, that's very crucial. Making sure that the footprint is as small as possible for these accelerator cards, so that customers have the maximum amount of space to put what really matters, like the central processor or DDR memory, things like that. And so that's what we're really seeing. So now to kind of jump into our devices and a little bit how those really play a key part in our solution offering. We're really talking right now about the core solutions, but jumping into the high current core solutions that we do offer at MPS. The first one being our 3695-25. So this device is a taller profile module, so it's really meant for top side of the board use, and that's really depending on, as I'll talk about how we stack our different module offerings. We have thinner profile, or we have ones for, like I said, top side of the board use, which would be like our 25-25 device. So this can supply up to 20 amps of continuous current, and we do see it used. We can parallel it up to 2 phases. And so we do see it used for several, if there's smaller rails that need to be used, or if you have a smaller device with like a NIC card or something like that, that needs a lower amount of current, then we can, supply, like I said, up to 40 amps continuous with 2 phases of this device. And that's actually been a, kind of a sweet spot for a lot of the smaller cards that are using, lower compute demand, processor demand current, is really in that 30 to 40 amps. So this is definitely a sweet spot in the core current supply. And it can do up to 50 amps of peak current. So this makes it so that if there is demand, or that a customer is seeing, or needs to be able to design to that, we do see it. But very compact solution size is one of the keys. So now jumping into our MPM82504, and this is a newer device, and as I had showed our demo that we did before for the accelerator card, this device can be paralleled up to 800 amps. It also offers great output flexibility, which then, as I'll show later on, we use for different solution types. But this is really a flexible device, really a game changer in the accelerator card, or for any kind of SoC power. We really offer, we focus on the key advantages with the simple layout that, we can reduce the amount of output capacitance that's needed, as I'll touch on, and the footprint is incredibly easy to lay out. We make the cap placement very simple, but we also really push the fast transient, which I have some detailed slides on. And we, the diagnostics and readback are key for accelerator cards, because now, like this device, our 82504, we offer telemetry and readback built in. So not only the flexibility of the rails, where you can combine, the quad output rails into any different configuration that you want, but now you can get, readback, current monitoring, temperature monitoring, voltage monitoring on all those rails. And so your SoC now can read those back through PM bus, and you can then dynamically manage your system better, which we're seeing is a huge step up for a lot of these cards, especially now that it's all one integrated device. Kind of talking about, as we mentioned, the really high performance requirements that are required for these accelerator cards. The transient response being a key part of this, where we can, maintain a very small undershoot, overshoot, even for a large transient step. And really the key is, the amount of capacitance that we need. So typically, a lot of the competition out there, especially for discretes or power modules, they'll need double the capacitance that we need. And that's really a key. If you look at our solution size, if you look at, the module size is small, but now the total solution size, we can cut the external capacitance that's needed in half, which is really a big step up from our competition. And that's really shown in our performance results, where we're able to not only hit the transient respects, but reduce the capacitance needed to do that. Also shown here from the 82504, this is a steady state 74 amps out, and we're maintaining a 5.8 millivolt peak-to-peak ripple with that minimal capacitance that I showed on the last slide. And this is really a testament to how good our technology is, our COT controlled devices like this one is, and that really provides a big performance increase over the competition. Just to kind of summarize, our big core power solutions, we have our MPM82504, which I was just discussing, which can be, flexible in the output, and we can tie them together. Or we have our 100 amp module solution, which is just a single 100 amp output, and they can both be paralleled up to 800 amps. So next, I want to jump into our split VN solution. This solution is something that we've really seen as a key benefit for the power module space. So as I was showing on our demo before, and I kind of to break it down more, is that our split VN solution is really to allow for dynamic power sourcing. So on a lot of these cards, as you see here in the upper portion of the card, there's a auxiliary power connector. So a lot of cards now, they're drawing over the power requirements that a standard PCIe slot can provide. So this means that they need to source power from the PCIe slot as well as source power from the auxiliary plug port. And so what a lot of customers are trying to do, and they haven't been able to do because a solution like ours doesn't exist, is they either have to switch from one to the other, or they have to tell which one's plugged in or not. Where we can dynamically, based on our two devices, we can dynamically sense which inputs are available, and then provide core power based on that, which can add a lot of flexibility, especially with our telemetry, our digital features. We can now provide that communication to the core. And so now you can have customers where if their core needs to be toned back because they only have PCI input, or they have both PCIe plus aux input, now you can change, your computing based on whether or not a customer is plugged in their board or they just have PCIe power. And we can support this up to 800 amps. And it really is where we can, current solution is that customers will use an OR-ing circuit, and this can be a very large circuit. It can also lose a lot of efficiency. And as I mentioned, the efficiency being such a key part, we went after it to remove this. So now our solution, we don't need this OR-ing circuit anymore to be able to dynamically source power from two points. And it is dynamic, so it's not it's actively switching, sensing for those different inputs. Just to kind of show the different scenarios and how we address them. The first scenario kind of being where the main supply is present, but the aux supply is not, and then our aux switchers remain idle, but our main supply is active. So scenario two, where the main and aux supplies are both present, and the main supply starts first. So then the main switchers are enabled after the main supply is ready, and the aux switch are disabled until the aux supply is ready. So we can really tell and make sure that we're dynamically sourcing power as needed. And then in the scenario three, the main and aux supplies are both present, but the aux supply will start first. So the switchers will not be enabled until the main supply is ready. And so just with our two devices, these are really the three power scenarios, right? You either have aux plus PCIe, or you have PCI plus aux, and then it depends which one comes up first. And then our solution can handle that so that we're always sourcing power correctly, and then providing that to the core, for core power. So this really allows for us to provide a very unique, compact solution to solve a key problem in the accelerator card market. Now, kind of moving on to our ultra thin module solution. So these have been key in allowing more flexibility for customers. Taking a look at, as a roadmap of all the different types of low profile modules that we offer, really being defined as less than 3.5 millimeters in height, but most of our modules here are either 2 millimeters or less, which is really a big advantage because, like I said, a lot of the solutions out there, the backside of the board is about 2 millimeters or less. So that means that we offer, all these different current ranges up to our 10 amp module, and this is for 12-volt input as well. And then we also offer low input voltage devices as well, all the way up to 6 amps. So as shown in that roadmap, we have several different low current devices that are able to fit on the backside of the board because of their ultra thin height. Our 3804 is one that I'm highlighting today, as it's only 1.6 millimeter height for those very, very low current aux rails. We do offer several other 1 amp solutions like our 3811, but our 3804 is definitely a great device for LDO replacement. And as I said, backside of the board use. So now you can move some of those, aux rails to the backside of the board and save that top side board space. Our 3822C, 33C, these are a 2 amp and a 3 amp device. And these have been very, very popular, very high runners for us here at MPS. They only have 1.6 millimeter height. So now we can also place those on the backside of the board. And we've seen these widely used because of the LDO replacement model that we've been able to attack with it. They're, a terrific solution for, as I mentioned, the aux rails, but really, the LDO replacement, because of their forced CCM operation, we're able to have a very, very small ripple and low noise performance. And this allows us to then meet some of those, some accelerator cards, depending on their application, their core compute device may have certain rails that need to be extremely low noise or low ripple that are lower current. Maybe some transceiver rails, things like that. And these are a lower current solution for that. We actually have a white paper on our website that talks about how these devices are able to achieve such low ripple and noise performance. And this was something that was actually shown and tested by Xilinx when they did one of their board tests. We were able to provide an LDO replacement. So I recommend checking this out on our website to kind of get an understanding of how we're able to replace, a low efficiency LDO with a high efficiency switcher, but yet still hit the noise and ripple requirements that a lot of these devices need. Jumping along to our 3632C, this device, can really be a key player in terms of its really low performance ripple. And now we're in, 12-volt solutions. So for a 3 amp device, this can be a very key player for the 4 CCM operation. Allows us to provide that same low noise solution. And this is also in a 1.6 millimeter package. So now, we can put this on the back side of the board. Looking to our 3650, we do have, this is a higher current solution now, looking at 6 amps of current, and, great for optical supply power, or as well as some aux power as well. And then one of our key featured devices is our MPM82504. This is a quad output device. It's a PMIC device that we have 4 rails. So this is really one of the ways I was mentioning before that, we can reduce the solution size further is with this device, because not only is it a 2 millimeter high package, so it could be placed on the back side of the board. It only needs 5 capacitors, and now you could cover 4 rails, or you can combine the rails to have a 6 and 4 amp solution. So it makes it a very, very compact, easy to use solution that we've seen, very successful in this market. And then the last module that I want to kind of, showcase for our low profile solutions and how we're addressing this accelerator card market to allow customers to place these on the back side of the board or under heatsink is our MPM3695-10. This device is up to 10 amps in only a 2 millimeter high package, and we can parallel it up to 6 phases. So up to 60 amps of output current, very compact solution. This offers full telemetry and PM bus. So now you can program the part, you can have readback available. So very, very good solution for this part. So this kind of something, just to briefly showcase our low profile solutions, as I was mentioning, when the solution needs to go under heatsink or on the back side of the board, we provide solutions for that. We also here at MPS, we have our 3D packaging modules where we're able to now stack the inductor on top of the IC, and that's in some of our module solutions. And as you can see here, we're able to now reduce the footprint space because we can go vertical. And so this makes it so it's a very, very compact solution and reduce the footprint space. One of our modules that we do this is our 3632S. So this is in a 3x3. It's also only 1.4 millimeters high. So it's in the same regard. It's also a low profile module, but we do stack the inductor to reduce the footprint size as well. This is a 3 amp device, 12 volts input, 4 CCM, so very low ripple. And then this has been a very common device for the footprint reduction is our 3683-7. So this is in a 4 millimeter high 7x7, but up to 8 amps of continuous 12 amp speed. So this device being a little taller, but we really reduce these footprint space that's required for this device. And so this can be an area, where now you can take advantage of more of the top side board space, other areas like that. As long as, like I mentioned, our core solutions too earlier, those are also kind of, in the same area that our top side board solutions. But this is just another way to which, we're providing these solutions that really fit in the requirements that are needed for accelerator cards. So just to kind of sum up, as what we've covered is that, MPS, we're really excited and going after this market, and we want to help you guys as designing these boards or going out and interfacing with these different customers, that we offer, the small size, footprint, and height solutions that make a difference in really allowing customers or you, the designer, to design in a power solution that doesn't now interfere with you having to reduce your computational or computer output. And we also offer the not only a compact solution, but the easy layout and the minimal footprint that's required for the total solution. So as our examples show, that we reduce the output capacitance that's needed, which really helps us tackle the total footprint size, and then as well as the high performance. Our transient response and the minimum capacitance that goes with that we can meet is really unmatched in the industry. And our low noise ripple performance, has already been showcased across other devices that are available and out there. And as I recommend, check out our white paper. But that's really how MPS has been able to attack and showcase our module solutions to be such a key provider for power solutions for accelerator cards. So I hope you all enjoyed this talk today. Like I said, we'll have a QA now, but this was really to showcase, how we're changing the industry, how we're keeping up to supply the industry with the power solution that it really needs to bring these accelerator cards into the future. So thank you very much for your time. And as I said, we'll open it up to QA.
Great, thanks, George. Lots of really good information today. As George mentioned, Q&A is now open. If you mouse over your Zoom webinar interface down on the bottom, you should see a Q&A button, and you can just click and type in there. We did have one question already, and that was just, is this presentation going to be available? And yes, we are recording the presentation. We will put it out on our website on monolithicpower.com/webinars. We are a little bit backlogged with our virtual electronica events all week, but by next week we'll have it there for sure, and we'll add the presentation as well, and we'll make sure to send an email out to everyone. Okay, I am not seeing any questions, but we'll give you a little more second. Again, anything you want to discuss, go ahead and drop it into the Q&A area. Okay, George's presentation must have been so thorough that there were no questions left. Thanks again for your time. We look forward to communicating more with you in the future. And with that, we will go ahead and end the presentation. Thank you.